Okay, there's no sound on this laptop, so I don't actually know when it's going to start, but probably I've started recording at this point. Hello, it's Miss Power. um, I am going to go through the Module 5 review. It's twice as long as a regular review because we're doing 2 tests, so bear with me. Yeah, we'll just do it all. I'll also mention that which proofs are on the group test and which kinds of proofs are on the individual test. The individual test, it's like I do the proof and you have to put them in the right order, or like I do these statements part and you have to fill in the reasons. And then the group proofs are going to be like the totally you're just proving it thing. But I'll mention that when I get to the review. Okay, let's go. For each problem below, nice, write an equation. Justify your equation with a definition, a theorem, or postulate. Use the properties of equality. You don't have to write the properties you use to find the value of x. When it says use the properties of equality, it just means do a bunch of algebra. All right, so this first one. I'm actually going to start with the justification. Call me wacky. Here we've got two vertical angles. When angles are right across from each other, they're called vertical, and it means they're congruent to each other. I'm going to use this fact to write my equation. My equation then becomes the two angles are equal to each other. So I'm going to say 5x minus 11 equals 2x plus 19 because these angles are equal to each other. Now, down here, I'm going to do some algebra. I'm going to say if 5x minus 11 is equal to 2x minus plus 19, what is x? I'm going to put all the x's on one side by canceling them from this side. I'm going to put all the numbers on this side from canceling them from this side. 19 plus 11 is 30. 5x minus 2x is 3x. And now to get x totally alone, I'm going to divide by 3 and get that x was 10. That's how these questions are going to go. So let's do it again. Start with my justification. How do these three angles relate to each other? Turns out that triangles' angles add up to 180, which is why I'm going to say these three angles added together are 180. Great. I'm just going to write my angles in. It does not matter what order. Minus 20. And now I'm going to do some algebra. So I've got 2x plus 3 plus x plus 15 plus 5x minus 20 equals 180. I'm going to add up the x's and get 2x plus x is 3x plus 5x is 8x. Now I'm going to add up the numbers. So this is plus 3 plus 15 minus 20. 3 plus 15 is 18, minus 20 is negative 2. Now I'm going to add 2 to both sides to get the x's more alone. And I'm going to divide by 8 on both sides to get the x's even more alone. Sometimes your answers are decimals, and that's just fine. Nice. Next one. I'm going to start with my justification. This angle and this angle are alternate interior angles, which means they're equal. So I'm going to set my two angles equal to each other. 8x minus 12. Nice. I am then going to solve that equation. Equals 8x minus 12. Whenever I have an x squared involved, I'm going to move everything to one side and set it equal to 0, right? By subtracting 8x from both sides and from adding 12 to both sides. Then, and I know you all love this, I'm going to factor. This is how we solve quadratics. I decided to factor, so I'm going to say what multiplies to 12 and adds to negative 8. That's negative 6 and negative 2. And then for the final answers, we switch the signs. This one will have 2 answers because it's a square. X squared will always have 2 answers, or usually have 2 answers. Cool. this angle and this angle are same side interior angles, and same side stuff always adds up to 180. So I'm going to say these two angles equals 180. 6x minus 10, 4x plus 30. And now over here, I'll do some algebra. 6x minus 10 plus 4x plus 30 equals 180. I'm going to add up my x's. I'm going to add up my numbers. Negative 10 plus 30 is positive 20. Then I'm going to subtract 20 on both sides. Then I'm going to divide by 10 on both sides. Cool. Let's skip the yellow because it's hard to read. Okay, this one's kind of funky. This one, the justification is exterior angles equal the remote interior angles. I don't mind if you just write exterior angles, but this is the full answer, which is it means that these two inside ones, so 7x and 2x plus 5, that doesn't look like a 5, equal 12x minus 16. So these two, those two added together equal this one. So we've got 7 plus 2x plus 5 equals 12x minus 16. I'm going to simplify these on this side before I get going. Then I'm going to subtract 9x from both sides to get all the x's together. I'm going to add 16 to both sides to get all the numbers together. And then I'm going to divide by 3 to get x by itself. 7. There we go. For these ones, the justification is if I've got two congruent triangles, so congruent, CT stands for congruent triangles, and I look at corresponding parts of them, so the C and the F here match up, they're corresponding to each other, then I can set those equal to each other. I can say the C is equal to the F because they agree in the sentence, even though they don't look the same. And I can say that 8x minus 11 is equal to 33. Then over here, I use algebra to solve this equation. Divide by. All right, next one. A little bit wackier. Same thing. Given this is a parallelogram, we've proven that the opposite sides of a parallelogram are equal. So we can make these two equations. And the reason for both of them is opposite sides of a parallelogram are congruent. And now I'm going to do some algebra. This algebra is a little bit trickier than the rest of them. So we've got two equations. Here's my first equation. And here's my second equation. Here's how I'm going to do this. I'm going to solve my first equation for b. So I'm going to subtract 4a from both sides and say that b is the same thing as 21 minus 4a. Great, I got b by itself. Now I'm going to rewrite this equation the exact same, except every time I see b, instead I'm going to put 21 minus 4a. Cool. What that does for me is because I've smushed this like this equation into this equation, now I have one equation with one variable, which I know how to solve. The first thing I'll do is distribute the -2. Then I'll add up the 3a and 8a to get 11a. Then I'll add 42 to both sides. So I did plus 42 plus 42. Here I just added these ones together. And now I'm going to divide both sides by 11 and get that a equals 5. Now that I know that a equals 5, I can plug that in here. And get that b equals 1. This is how I'd solve this. This is called system of equations, and specifically this method is called substitution. You can also do elimination, which I like better, but y'all tend to like substitution better. So if you want to learn elimination, tell me. Okay, number 3. Sketch a picture to illustrate the meaning of the following words. Be sure to mark your figures. Okay, a linear pair is what we've been calling straight angles. Straight angles. It's just two things that are right next to each other that add up to 180. So like these two are linear pairs. Let me get a better color. These two are linear pairs. Supplementary means it adds up to 180, right? These are supplementary, but they want you to find supplementary angles that aren't a linear pair. So I'm going to write parallel lines cut by a transversal, and I'll say that these two definitely add to 180, but aren't right next to each other. Another example would be like these two. Notice that it's both of the same side angle pairs. So like same side interior is the orange, same side exterior is the green. All right. An altitude. Altitude starting at vertex A means it goes straight down to the other side and meets at a right angle. So altitude meets at a right angle. Angle bisector from the vertex G. Oh, I did this wrong on the answer key then. Angle bisector from the vertex G means that this angle is the same as this angle, and we started at G. Median from the vertex A means it starts at A and ends right in the middle of the other side. And then perpendicular bisector. Bisector means middle. So we start in the middle of AG, and then perpendicular means a right angle. And it doesn't hit the vertex at all. Place M so that it's the midpoint. The midpoint just is in the very middle. DK such that it bisects NDB. So we can write any angle NDB. So D definitely has to be in the middle, and then just like N and B have to be the start and the stop points. We could have switched N and B, that's not a problem. And then DK, such that it bisects this angle, means we're cutting this angle in half. This side is equal to this side, and this is a K. A rhombus is any four-sided shape that has the same side lengths. So if all of these are the same, that's a rhombus. Square is that four sides are the same and they're 90-degree angles. Right? Rectangle is just that they're 90-degree angles. And then parallelogram, the actual definition of parallelogram is just that these two are parallel and these two are parallel. It turns out there's a bunch of stuff that's true about rectangles and true about parallelograms and true about rhombuses, but these are the definitions. Nice. This one, so let's just go up and over. All right, here is where the madness happens. We are now going to fill out this entire diagram. I'm going to get a tiny thing. Can y'all still read that? Yeah. Yes, I'll stay with 3. I'm just going to fill these out. Then I'll put them down and do the reasons afterwards. But let's just do this. All right. A is across from 64, which means it's vertical with 64, which means that it's 64. Great. D is corresponding with 64. It's in the same spot, just up a level. So it's also 64. B is right next to 64, which means 180 minus 64 equals B. 180 minus 64 is 116. Let me not forget these. Same thing here. C is right next to D. So we're going to do 180 minus 64 to get 116. Let me fill this in so far. Right? Whereas this one, we just matched them up right here. And with these ones, they were across from each other. Okay, over here. P is 90 because it's right next to another 90. N is 79 because it's right across from a 79. It's vertical with 79. What are the other one nice ones? T and 61 are right next to each other, so they're going to equal this one's 180 minus 61. Right. 180 minus 61. M is this one next to 75. So 180 minus 75. That's going to be 105 for M. E is right across from 108. That means it's going to be 108. G, I, and K are all corresponding with 108. So these are all 108 as well. J is across from I, vertical with I, so it's 108. S is right next to K, so it's 180 minus 108, because they're linear pairs or straight angles. Oh, I mentioned H is right next to it, so that's going to be 72 as well. And then I think the only one left is Q. Q, hilariously, is this line is parallel to this line, which is parallel to this line. So B and Q are corresponding. So they're going to be the same thing, 116. No. Cool. That's that done. So I'm actually going to scroll down and fill these in now. So A was 64 because it was vertical. It was across from 64. B was 116 because it was a linear pair with 64. We can call this straight angle because it's what we've been calling it. C was alternate exterior with B. That's how I like to think of it. Let's just do D first. D was corresponding with 64, and then C was a straight angle with D. So C was, oh my god, this is going to be a nightmare. This one was corresponding. This one was straight or a linear pair. E and F. E, where is E? E was across from 108 over there. So that's vertical, and F was right next to it, so that's a linear pair. G and H. Oh, G, I, and K were all corresponding because they're all in the same place as this 108. So G, I, and K. Nope. Corresponding. Nice. What am I missing now? H, J. H and J. Okay, so J was vertical with I, so right across from I, and H was right next to G. So this one is a linear pair or a straight angle. And then J was corresponding, or sorry, vertical. So that's going to be 108 as well. M and N. Oh, goodness. M was right next to 75, so that's a linear pair. N was right across from 79, so that's vertical. So this is linear pair and vertical. And then what was M? 105, that makes sense. Oh, this is silly. Okay. P. P was right next to 90, so linear pair with 90. Q was corresponding with B. Right? We said that Q and B were the same thing. Those are the yellow arrows. And then S and T. S is right next to K, and T is right next to 61. So they're both right next to something, and then X and K. So this is 72. All right. Next. For each pair of triangles, write if they're congruent or not. So the congruency statements are side, 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 angle, angle, side, angle, angle, side, and then hypotenuse L, hypotenuse length, which is just side, side, angle, but only for right triangles. Nice. So let's check out which ones we can find. This, to me, looks like side, angle, side. We've got a side on both, angle in between them, and a side. That means they are congruent. And now when we write these triangle congruencies, we have to be really careful. We want the P to match up with the U. We want the R to match up with the S. And we want the T to match up with the Q. So if P was first in this one, we should put U first in this one. If R was last, S should be last. And if Q was second, it should be like this. Right? We have to be really careful to write these in the right order because the order we write them in is saying which parts match up, which parts correspond to each other. All right. Anytime we've got something where the triangles share sides, that means it's for free. They get the same side. This one looks like angle, side, angle. The W in this triangle matches up with the Z in this one because they're both the ones with the two angle lines. The Y matches up with the X, and the Z matches up with the W. This one is angle, 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 which is not one of our things, so we say it's not congruent. All right. Here, we've got side, side, angle, but also it's a right triangle. So that means it's actually hypotenuse leg. We're good. The W matches up with the Y, the X matches up with the X, and the Z matches up with the Z. This one, we've got three sides. The S is across from the one with one tick. So S is going to match up with C. The A is across from the three ticks. So A is going to match up with T. And then the I is the other one. So it's definitely going to be the N. Nice. Given that DEF equals or is congruent to VWZ, state the corresponding congruency. I honestly don't even need the picture for this one, right? This one, they already told me that D matches up with V. So every time I see a V or a D, I can just write in the other one. They told me that the E matches up with the W. So anytime I see a W, I can write an E. And then the F matches up with the Z. So anytime I see a Z, I can write an F. And anytime I write an F, I can write a Z. And then I should write in like angle and then this stuff. we really wanted to, we could say that E, oh, this is definitely supposed to be an E, not an F. Gross. E and W are the same. V and D are the same. And Z and... Oh, no, I lied. That is supposed to be an F. Nice. Okay. F and Z, E and W, D and V. Cool. Okay, use what you know about triangles and parallelograms to find each measure. This one, and I did this one with a couple of y'all, this one I'm actually going to fill in everything before I start. I'm really interested in that. So this orange line is 24. So this one is also going to be 24. This green line marked with one tick mark is 30. So all of these green lines are 30. Boom, boom, boom. Let me... Oh, sorry. This blue angle is 55, so all of these angles are 55 as well. All of these red angles up top are also going to be the same, and up down bottom. And we can figure out what they are because we know that these are right angles because it's a rhombus. So this one up top is going to be 180 minus 90 minus 55, which is 35. So all of these are 35 degrees. And the only thing we're missing is this line and this line. Right? We know this is 24. We don't know this one, and we do know this one. We can use the Pythagorean theorem to solve for x. So this 24 times 24 is 576. 30 times 30 is 900. If I subtract 576 from both sides, I get 324. And then if I square root both sides, I get that x is 18. It's good, because I wanted to know that. So then this is 18, and then this is 18. All right, now let's answer our questions. From x to z, that's the line. It's going to be 24 plus 24, which is 48. That's that orange line. We do the lines first. Y to x is just from here to here, at 30. And then from y to w is 18 plus 18, which is 36. If I really wanted, full points slash, to be super correct, I'd write meters, which is what the m is. All right, now let's do some angles. X, Y, Z is this angle, right? This purple angle. So what's going to happen is we're going to add these two 55s together. So 55 plus 55 is 110. Then what's the next one? X, Y, W. X to Y to W is this angle. That's just 55. Then Y, X to Z is just this angle up top, just 35. These are a lot easier to find once you fill out the diagram. All right, new diagram. Let's fill it out. We've got 80 is across from another 80. There's vertical angles. It's right next to a 100 because these right next to each other angles need to add up to 180. If this line is 10, then so is this one. If this line is 18, then so is this one. This line down here is 22, and so is this one up here. If this angle is, oh my God, what did I say what it was? Did I say 23? Let's say 23. Then this one up here is also 23 because of alternate interior angles. Similarly, if this is 68, then this one over here is 68 because of alternate interior angles. I now have a triangle over here where I know two of the angles, but not the third one. So this angle is just 180 minus 100 minus 80, which is 57. Same thing for this bottom triangle, so I can just write this in as 57. And then this one, similarly, this entire triangle has to add up to 180. We already got 80 and 68. So this one is going to be 32. And we add those together and subtract them from 180. Okay, enough prep work. Let's find the actual lines. I do sines first. So L to G is 18. They actually gave us that one. H to F is this entire thing, which is 10 plus 10, because this one's 10 and this one's 10. Okay. F to G right here is 22. Then E to G is 18 plus 18 is 36. Again, if I wanted full points, and to feel good about being totally right, I would put in my units. All right, now for angles. EHG, starting at E, going to H, and ending at G means I want this angle, which means I want these two added together. So I'm going to do 68 plus 57 and get 125, I think. Seems right. Yeah. FEH, starting at F, going to E, ending at H, FEH. I'm going to add these two together. 32 plus 23 is 55. Elf, E to F, that's 80. FGE, FG to E, let's go down here. So that's just this 23. All right. Last little column. Oh, nice, the proofs. Woo! Best part. Okay, number 8 and number 10 look more like what you're going to get on your individual test, where I do a lot of the proof and you're going to fill stuff out. Whereas proof 9 and 11 look more like the group test, where I'm just going to make you prove something and you're just going to prove it. So let's go. The first thing to prove is always the given. So honestly, I'm just going to copy and paste this. AD is parallel to EG, and BF is parallel to CH. It was given. That's what I got to write it. Why is angle 1 equal to angle 2? These are alternate interior angles. So alternate interior angles. Then to be honest, we can figure out which ones are corresponding. 1 and 2 are not corresponding. 1 and 3 are not corresponding. 1 and 4 are not corresponding. But 2 and 3 are, if you look at these two being the parallel lines, and this being what you call a transversal. So 2 and 3 are corresponding angles, which means they're equal. 3 and 4 are across from each other. So that means they're vertical angles. And then the reason 1 is equal to 4 is because we have 1 here is equal to 2, which is equal to 3, which is equal to 4. All right, let me draw this snake better. 1 is equal to 2, which is equal to 3, which is equal to 4, right? And that's why they're equal to each other. We call that transitive property. And then we've showed the thing we want, so we are finished. Nice. Okay. This one we're just going to write, right? I like to figure it out on the diagram first, and then afterwards just write down what I said. So I'm going to do it in a rainbow order so I remember what order I was doing. They told me that SE equals SU. That was given. They also told me that angle E was equal to angle U. That was given. I can see that angle 1 is equal to angle 2 because they're vertical with each other. They're right across from each other. Which means by angle side angle, this whole triangle is equal to this whole triangle. Once I know that those triangles are equal, I get to say that these things are equal, which is what I wanted, because congruent or corresponding parts of congruent triangles are congruent. The different parts of equal triangles have to be equal to each other. And then I'm done, because I showed what I wanted to show. So let's write down what I just said. I said that SE is equal to SU because they told me to. Right? I said that angle E was congruent to angle U. Again, they told me this. I said that angle 1 was equal to angle 2 because they were vertical with each other. I said that these two triangles were congruent by angle, side, angle. And I have to be very careful how I name the triangles. I'm going to name this one ESM, and then E matches up with U, so I'll write that one first. S matches up with S, so I'll write that one second. And M matches up with O, so I'll write that one third. And then finally, I get to say that MS is congruent to OS because corresponding parts of congruent triangles are congruent. Cool. This one, they told me that lean is a parallelogram, and I want to show that E and A bisect each other. First off, I changed this on the board. It should be lean, and this one is like, oh, I don't know. LE is parallel to AN. All right, lean is a parallelogram, that's given. These two are parallel by the definition of parallelogram. And then, so like, that's what I just wrote for these ones. These ones are also parallel by the definition of parallelogram, which is what's going to go here. Nope. EA and LN by the definition of parallelogram. The definition only says the two sides are parallel. Okay. Why is angle LET, this one, congruent to what? LET is congruent to NAT, or sorry, ANT. And that's because they're alternate interior angles. Similarly, ELT, so this one, is congruent to NAT, so this one also by alternate interior. Good. If we want to show opposite sides of a parallelogram are congruent, we could show that these two are congruent, but that doesn't really help us with the triangle that we're clearly building with this red and this orange angle. So let's say that these two are equal, LE and AN. That way I can show that this triangle and this triangle are congruent. And the way I can do it is angle, side, angle. Right, so by angle, side, angle, these two triangles are congruent. If I wrote the L first, I should write the A first on the other side because they're both the red angle. If I wrote the E second, I should write the N second. And then I'll write the T last. Now I can say, what is ET equal to? ET is this one. It's right next to the orange angle. So it's going to equal TN, which is also right next to the orange angle. And then the other two parts here are also equal, LT and TA. And that's by corresponding parts of congruent triangles are congruent. And the very last thing, very last statement should always be what we were trying to show. So we can just copy and paste that. EN and LA. EN and LA bisect each other. And we're done. Last proof, y'all. We can do it. We can do it. We can do it. Okay, definition of a dart is a concave kite. Recall that a kite is a quadrilateral with two distinct pairs of consecutive congruent sides. So in order to show that ABCD is a dart, we have to show that AC is equal to BC and that AD is equal to DE. This is a B, so this is probably a B. Great. Let's get it. Okay, so we'll start with the given. AC is congruent to BC because they told us. And already we've checked off one of our things. Nice. They also told us that ACD was congruent to BCD, the angles. So ACD is this angle. It's congruent to this angle. And again, that was given to us. So we'll write given. I know that CD is equal to itself. I know that because it's obvious, but also we call it the reflexive property. Now I can show that these two triangles are congruent. I can show that by side, angle, side. That these two triangles are congruent. And I have to be careful. If I put the A first, the B has to be first on this one. And then the C, D are in the same order because they're in the same side order. All this is to show that AD is equal to DB because of congruent parts, corresponding parts of congruent triangles are congruent. So that's AD congruent to DB. And now, because I've checked off the two things that I needed for this definition, I get to write this. The thing I'm trying to prove in the very last thing is a dart. And we get to say that because we checked off the definition of dart. Nice. Whew, y'all, that's that for that. Okay. If you want more help, I will be at school tomorrow at 7:30. I will stay after school if you want help with the individual thing, and I'll be at school tomorrow at 7:30, or on Friday at 7:30 in the morning as well. All right, I'm gonna go upload this. Good luck.